So what's going on with stucco? Why do we have more problems with stucco today than we've had in the past? Stucco is a traditional cladding system. It goes back thousands of years. And the problem is that we've changed the way that we do stucco. First of all, we put the stucco over highly insulated assemblies. We didn't used to do that. We also put stucco over engineered wood products such as OSB when we used to put them over plywood and boards. We've also changed the physical characteristics of the stucco. Today's stuccos don't breathe as well as the old stuccos. Those changes have led to significant problems with stucco. As a result, we have to change the way we build stucco today so that it provides an excellent service life. Moisture problems are more prevalent today because we've changed quite significantly the way we build a modern building. We have much more insulation in the building, and that's both a good thing and a bad thing. The good thing is it saves a great deal of energy. People become more comfortable. The bad thing is that there's less energy movement from the inside out and the outside in, and energy is required for drying. So one of the issues we have to deal with is that as we become more energy efficient, buildings stay wet longer. So we now have to focus more on preventing them from getting wet in the first place. The secret is to provide a gap between the stucco and the substrates. We need an airspace between stucco and the rest of the wall. It's all about the space. If we have the right kind of a space, stucco will last hundreds of years. We have a reservoir cladding here with an air gap and a wall. What happens is rainwater hits the reservoir cladding and is absorbed by the reservoir cladding. Sun hits the reservoir cladding, drives the water in, and this water can evaporate to the interior into the air gap. And how we deal with that requires two different strategies. One is a very effective strategy where we ventilate the airspace, intercepting the inwardly driven moisture. So it gets blown through the cladding and it's intercepted before it can cause damage at the back of the wall. The second approach is to intercept the inwardly driven vapor with a vapor throttle, such as a dimple sheet. The moisture is driven in, but it's stopped at this location, and that way we don't require back ventilation. All that we require is drainage. This gap disconnects the cladding system. It uncouples it from the rest of the assembly, thereby giving it back its longevity and its durability. If we don't do this, the cladding systems will not last. They're not lasting now.